Hello everyone, welcome back to Biophilia, your all-time study mate. Today we are going to continue the chapter with its part 3 about urine formation. If you like this video and get some help, then don't forget to like, share and subscribe to our amazing channel Biophilia. So in the previous two parts of this chapter, we had seen about the different organs of human excretory system और उसके बाद हमने second part में देखा था in detail about the nephrons. So after all the discussion about the structures and all the organs present in the system, now we are going to see about how actually the system is going to work for urine formation. So urine formation mein there are going to be majorly three processes that are involved. The first one is called as glomerular filtration. The second one is going to be reabsorption and the third is secretion. So glomerular filtration क्या है? Filtration word everyone very well understands. And there is going to be sieve like छलनी होती है जैसे चाय को छलते हैं जैसे चाय को हमने छला है ओके यहाँ से पोर करोगे and in the lower cup you are going to get the filtrate over here that you can drink very well. So this is going to be filtered और चाय पत्ती कहाँ पे रह जाएंगे यहाँ पे tea leaves रह जाएंगे. So that is what is going to exactly happen, that is the glomerular filtration. Reabsorption होगा and then there will be some chemicals which will be secreted into here. So we will discuss now in detail about all these processes one by one. So the first one is going to be glomerular filtration. Now the first step is going to be कि जो भी चीज़ें हमें चाहिए और जो चीज़ें नहीं चाहिए दोनों को separate out करना है. Separate कैसे करेंगे? We are going to use the method of filtration. So filtration from the blood is going to occur. That is the first major step that is occurring. And since it is done because of glomerulus, it will be called as glomerular filtration. So how much is going to be the filtration rate या कितना filtration हो रहा है? Then it is going to be on an average about 1100 to 1200 milliliters of blood that is going to get filtered per minute. That is about roughly 1/5 of the total blood which is pumped out by each ventricle. So that is about you understand कि 1/5 part 1 minute में हो रहा है. So the blood needs to get 5 times pumped through the kidney so that the entire blood gets filtered out once. So that is one thing that you can understand from this one. So now what is going to be the place? जैसे आप चाय को छलते हो तो for that you are going to use a strainer. Now, in the case of our glomerular filtration, where in the kidney we are going to have that sieve और वहाँ पे क्या होगा जिसकी वजह से filtration possible है. So the first thing that is allowing the filtration, for filtration you need a mesh-like structure कि उसमें एक definite hole size हो कि ये holes में से चीजें pass हो सके and the bigger place does not get and it will get filtered out. So ये mesh work हो या कोई ऐसे जाली बनी हुई हो तो ये जाली जैसा जो स्ट्रक्चर फॉर्म करना है so that there can be filtration slits or filtration pores. These are going to be formed because of cells of epithelium which are called as podocytes. So podocytes क्या होते हैं? Podo is a word that is referring to feet. So these are going to have some feet-like interdigitations because of which there is going to be formation of these slits or these pores जहाँ से filtration possible है. So this blood is going to get filtered out through membranes. Now what sort of membranes is it going to get filtered through? So blood is going to get filtered because of some force. जैसे फिल्ट्रेशन जो आप चाय उबालने के बाद फिल्टर करते हो या पानी का जो वाटर प्यूरिफिकेशन मशीन होता है उसको फिल्टर करने के लिए भी क्या यूज होता है? पंप यूज होता है. So here what is going to be the driving force for the filtration? It is going to be called as glomerular capillary blood pressure. What is it going to be? It will be called as glomerular capillary blood pressure. Now since as you know that glomerulus is going to be made up of a tuft of capillaries and these capillaries have blood flowing through them, that blood is flowing at some pressure और वो pressure की वजह से the filtration is going to be possible. So now the filtration is occurring through membranes, and what is this membrane constituted of? So membrane is going to have 3 layers. And this three-layered membrane is going to be called as filtration membrane. Why so? Because you know that it is going to be, needed, or it is used for the filtration purpose in the glomerulus. So it is called as the filtration membrane. Now what are these three layers? So these three layers, the first layer is going to be of the endothelium. और endothelium किसका है? It is the endothelium of the blood vessels. So जो capillaries है, जो tuft of capillaries है in the glomerulus, these are going to have endothelium. उसकी एक layer बन जाएगी. Second layer जो होगी, it is going to be of the epithelium. Epithelium किसका? जो podocytes है उनकी भी तो top epithelium layer होगी. So epithelium layer of the Bowman's cells. Bowman capsule में जो cells है, these Bowman capsule cells also have the membrane, तो वहां से भी पास होना जरूरी है. And the third layer through which it will pass is going to be very important to understand. epithelium है. तो epithelium के cells किस पे lay down करते हैं? They are going to lie on the basement membrane. So since there is going to be epithelium, so there needs to be a basement membrane as well. So there is going to be basement membrane between the layer 1 and between the layer 2. So that is the making of three layers of the filtration membrane. So अब जब blood ये three layers में से pass होगा, now what is going to be, going through and what is going to get stopped? It depends upon the size and the pressure. And of this, that it is allowing some of them, and some of the proteins or some of the other substances are not allowed to pass through that filtration membrane, और वो वापस blood में circulate हो जाते हैं. इस process को क्या बोलेंगे? You are going to call it the ultrafiltration. So that is about the glomerular filtration. The next is tubular reabsorption. So as you know that आप urine कितनी pass करोगे? It might be around say 1 liter, 2 liters per day. But how much blood is going to get, pumped out every time through this glomerular filtration? It is going to be about 1100 to 1200 per minute. So in a way you can understand कि 1 minute है और उसको calculation से you can think कि जितना amount filtrate form हो रहा है, it is about 180 liters, but urine that you are releasing out is only about 1.5 liters. So ये जो difference आ रहा है वो कहाँ जा रहा है? So you might think about it, and the reason for it is going to be the difference comes because of the reabsorption. So about 99% of the filtrate is going to get reabsorbed by the renal tubules. और renal tubules में कौन कौन आता है? As we had discussed earlier as well, renal tubules may you are going to have Bowman's capsule. Then you are going to speak about the proximal convoluted tubule, loop of Henle, then the distal convoluted tubule and the collecting duct. But majorly, Bowman's capsule doesn't play any role in reabsorption as much, whereas PCT is going to be the major one who is going to support for the reabsorption. Right, and one of the part, that is DCT is also going to act for the conditional reabsorption. So we'll see in detail one by one of these functions as well. But for now, what is the reason that the changes are occurring between the amount of filtrate and amount of urine formed? The second step, that is the tubular reabsorption. So ये reabsorption कहाँ पे हो रहा है और कैसे हो रहा है? So the tubular reabsorption is occurring in the renal tubules, and renal tubules में who is helping out for it? The tubular epithelial cells. So जो cells tubular tubes बना रहे हैं, those are only going to help for reabsorption. That can be either an active process, यानी ATP use हो रहा है, or else it is a passive process wherein ATP is not used. So what goes through active reabsorption and what goes through passive? So substances like glucose, then amino acids, then ammonium, sodium ions, these are going to get actively absorbed, whereas you can think of nitrogenous waste which are going to go passively transported. So nitrogenous waste may you can think of urea, as in humans, urea is going to be major of the nitrogenous waste. And reabsorption of water is also going to act for passively in the initial segments of nephron. So because of majorly water is getting absorbed and other substances are also getting absorbed, that is going to be decreasing the amount of urine formation. Now here in the diagram also you can understand the different functions of different parts of the nephron. So parts of nephron we have already covered in the part 2 of this chapter. If you still want to learn in much more detail, then you can surely go and check out the link in the description box wherein the parts of nephron will be shared in much more detail. So here are some functions that these parts are going to play in the urine formation. The next third step is going to be tubular secretion. So this phenomenon wherein some cells, what cells? The tubular cells, these are going to secrete what substance? The substance is metabolic waste. This metabolic waste, when is secreted by the tubular cells, it is joining into the filtrate. और ये कहाँ पे generally join होता है? So secretion is majorly done by the DCT and even sometimes in the case of collecting tubules. So there is going to be secretion of K+, H+, ammonia, creatinine, some drugs, some pigments, or even some toxins. So how come drugs are coming into the urine secretion? The reason is going to be some drugs, or drugs, not necessarily the drugs that are bad guys, but the medicines are also drugs. So these medicines sometimes have their output pathway that comes out through the urine. So जैसे आपने एक बुखार आया है, बुखार आने के बाद आपने पैरासिटामोल खा ली, तो हो सकता है कि instead of not the example paracetamol but any other medicine or any other tablet that you eat, this tablet after functioning, say for example आपने सर दर्द की गोली खाई, आपका सर दर्द 6 घंटे तक सही था, and then the effect started to decrease. Now why did the effect start to decrease? Because now the drug's action is over and now the drug is getting disintegrated, and now where is it going to go? Now in a way it is a foreign substance to the body and body needs to throw it out. Now how is that medicine that you had taken in is going out? So once it reaches into the blood में से kidney पे जाएगा और kidney से वहां से it is going to get excreted out in the form of secretions from the tubular cells. So tubular cells ये drugs को या ये जो गोलियां खाई थी ये गोलियों को through urine it will be passed out. Similarly, some toxins can also be thrown out, and because of urine sampling or urine collection के बाद the people can understand whether what sort of drugs were consumed or what sort of toxins had ingested in the human body. So that is the one thing that you can understand from the drugs and the toxins which are going to be secreted by these tubular cells. Now only the mode of excretion. Now drugs is not needed by the body, the toxins are not needed by the body, so it is an excretion, but this excretion is not occurring in the case of glomeruli as per it is going to occur because of the secretion through the tubular cells. So ये tubular secretion जो होता है, it is going to act a very important step in the urine formation because it is also going to help you to maintain the ionic balance as well as acid base balance. So because many ions are going to be released, like K+, H+, all these are released. Because of that, the ionic as well as acid base balance is maintained. So that was about the third step in the urine formation. Now here we see the different functions related to urine formation in the different parts of these renal tubules. So renal tubules, as we all know, we have to study about the PCT, that is proximal convoluted tubule. Then we have to see about loop of Henle. Then we study about the DCT, that is distal convoluted tubule. And then finally we study the collecting tubule. So proximal convoluted tubule is going to be lined by simple cuboidal brush border epithelium. Now why brush border? As I told you, brush border microvilli is going to be essential for increasing the area for reabsorption. Now this reabsorption is going to be of the essential nutrients. Electrolytes absorb होंगे, water absorb होगा, because PCT is going to be major absorbing site. What is it going to be? It is going to be the major reabsorbing, not absorbing. You can say it is going to be a major reabsorbing site. right? So major of the water, electrolytes, nutrients सब यहाँ से reabsorb हो जाएगा, and then because of the reabsorption it is going to help to maintain the pH ionic balance through the secretion or reabsorption of different sort of ions. So that was about the PCT. Now the loop of Henle. Now loop of Henle, as you might understand, that PCT is going to be the major site of reabsorption, whereas in the case of loop of Henle में दो loops होते हैं. One loop which is going to be the descending loop, and other loop is going to be one that is ascending. So one is going downwards deep into the medulla, second one is rising out of the medulla and going towards the cortex. So these two limbs of the loop of Henle are going to act differently. So in the case of the ascending loop में reabsorption कम है, whereas in the case of descending loop reabsorption can be understood. It can be possible in the case of descending loop. So descending loop में क्या होता है? Descending में there is going to be water which is allowed to go in. So water is permeable to move in and out, whereas in the ascending loop it is not allowed for water to move in and out, whereas in the ascending limb the solutes are permeable, right? एक साइड से पानी अंदर बाहर कर सकता है, एक साइड से solute अंदर बाहर कर सकता है, and because of this mechanism that water in one side permeable, second it is not, and it is completely opposite to the ascending and the descending loop, because of which it is called as counter current mechanism. What is it called? It is called as counter current mechanism, and this mechanism is allowing for the concentration of the filtrate, and this concentration of filtrate is nothing but concentration of the urine. So ascending limb is going to be impermeable for water, and all this concentrated filtrate is going to move up and go into the collecting tubule. So now let's move to the next part, that is going to be about the DCT. So DCT is going to have the conditional reabsorption, यानी यहाँ पे कुछ ही चीजें ऐसी absorb होंगी that is needed for some maintenance purpose. So there is going to be selective reabsorption of ions, there can be selective secretion as well, so that the maintenance of pH and the acid base balance is maintained over here. So that is about the DCT. Very important to remember, that is the conditional reabsorption, whereas maximum absorption is going to take place in the case of PCT. The last part, that is the collecting duct. In collecting duct, it is a long duct which is going to join in many DCTs. ये एक लंबी सी collecting duct हो गई. ये collecting duct में there are going to be many DCTs which will be coming from different nephrons and coming together on a simple collecting duct. As the name collecting, you can understand many DCTs are coming over here. So this is going to extend from the cortex of the kidney to the inner parts of the medulla. So ऊपर कौन होगा? ऊपर होगा सबसे पहले cortex, then you go deep into it, then you will find the outer medulla. After outer medulla, you are going to find the inner medulla. So lower you go, you are going to go deeper into the kidney. So this is your deeper kidney, and this is going to be the upper part where the cortex is. It is your superficial kidney. So that is one thing that you need to understand. So collecting duct कहाँ से कहाँ जाएगा? It will go from the superficial end to the deeper end of the kidney. Large amounts of water is going to be reabsorbed because collecting duct का भी काम क्या दिया है? To produce concentrated urine. So one thing that you need to always remember कि जब तक DCT में है, till it is in the DCT, it is called as filtrate. As soon as it is entering into the collecting duct, the filtrate now will be called as urine. So once the fluid enters into collecting duct, it is called as urine. Until before the collecting duct, it is called as filtrate. So that is one terminology that you have to change according to the location of the fluid. So this segment, that is the collecting duct, is going to allow a small amount of urea. Now why urea is allowed to freely move out? Because the medullary interstitium needs to keep up with the osmolarity, and because of the osmolarity it is going to be possible for concentrating the urine. So now we will understand in detail about how this osmolarity is going to be set up in human kidney and how is it going to play a role in concentration of urine. So just wait for a few minutes and that will also be clear to you. Then finally, the collecting duct is going to maintain the role of pH and ionic balance as because of the secretion of the different ions. So that was pretty easy to understand about the functions regarding the urine formation with the reference to the different renal tubules. Now moving to the very important topic, that is how is the mechanism of concentration of the filtrate. Now the filtrate is going to be formed once the blood is getting filtered because of the glomerular filtration. So this in a way can also be called as the counter current mechanism that we had seen. Counter current mechanism में क्या होने वाला है? One limb is going to be opposite to the other one. Now how is it going to be opposite? Let us understand over here. So counter current mechanism, descending limb is water impermeable, whereas ascending limb is going to be water permeable. And now what is that? The difference of counter current mechanism that helps in concentration. So यहाँ पे सबसे पहले pathway जान लेते हैं what is going to exactly happen in these nephrons. So we have taken out one simple nephron in the center, and this nephron has been nearer to the collecting tubule, or you can say collecting duct, and on this side we have the vasa recta. Now what is it exactly? Let us understand. First of all, the efferent arteriole has been a division or a part of the renal artery. It has come nearer to the glomerulus because the efferent arteriole जहाँ से blood अंदर आ रहा था, अब ये blood different capillaries के through glomerulus में पहुंच चुका है, and now this glomerulus is going to do what? It is going to have filtration membrane. Because of the podocytes, the filtration slits or filtration pores, now there is going to be formation of the filtrate. अब ये filtrate कहाँ जाएगा? Filtrate will go into the blind cup-like structure, that is the Bowman's capsule. Or Bowman's capsule से it will enter into the PCT. Now once it has entered into the PCT, the remaining thing that could not pass through the slits will return back into the form of efferent arteriole. As I told you, the trick E is for E. So E से exit हो रहा है. So the things that could not get through into the filtrate, rest of the things will go into the efferent arteriole and it will go into and connect as vasa recta. So that was about the glomerulus. Now as the filtrate has entered into the PCT, PCT में जाने के बाद it is going to enter into the cortex. अब cortex में क्या है? Cortex में there is going to be some osmolarity. So 300 millios per mole is going to be the approximate osmolarity of the cortex. And because of that, जैसे ही filtrate form होता है in the initial stages of PCT, it is going to attain the same osmolarity of about 300, and as it goes down and down deep into the medulla, it is going to gain its osmolarity. So वहाँ पे क्या हो जाएगा? 400 reach होगा, 600 reach होगा. So once it reaches the outer medulla, what is going to be the approximate osmolarity? It can reach about 600 millios per mole. And why is it going to occur? Because as it going down, what is happening? The surrounding. अभी समझो ये एक बर्तन है, ये बर्तन में आपने क्या किया है? आपने थोड़ा नमक डाला है और नमक डालने के बाद आपने उसमें पानी भर दिया. अब पानी भरने के बाद what you have done? You have kept this thing porous. That means there are some pores. The water can flow in and out. और बाहर आपने पूरा साफ पानी, clean water, you have kept clean water outside the particular container. Now what is going to happen, as you know very well, there is going to be osmosis. What is going to happen? Since it is water, it is osmosis या फिर diffusion भी कह सकते हो, it is in the case of gases. अब क्या होगा, यहाँ पे जो आपने यहाँ की जो कॉन्सेंट्रेशन रखी है या यहाँ पे जो आपने ऑस्मोलैरिटी रखी है, the osmolarity over here in this cup is more than as compared to the osmolarity outside the container. So that is low. Now what will happen, because of the differences in the osmolarity, the solvent is going to move. The solvent is going to move, and from where does it move? Solvent is going to move where the solute is less. ओके, द वाटर इज गोइंग टू गो आउट. अब जैसे यहाँ पे आपने देखा कि नेफ्रॉन में, पीसीटी में, व्हाट इज लूप ऑफ हेनली में क्या होने वाला है, लूप ऑफ हेनली में द फिल्ट्रेट इज गोइंग टू हैव ऑस्मोलैरिटी इज लो. The condition discussed over here is opposite. Say for example, to keep it same, लेट अस कंसिडर कि बाहर का जो ऑस्मोलैरिटी है वो बहुत ज्यादा है, यहाँ पे बहुत सारे सोल्यूट है, बिकॉज यहाँ पे ऑस्मोलैरिटी कितनी है, यहाँ पे 600 मिलीऑस है. द आउटर एनवायरमेंट, द इनर एनवायरमेंट इज ओनली 400 millios per mole, and because of that what is going to happen, the solvent is going to move where the solute is more. Very important to understand, solvent moves where solute is more. So solute जहाँ ज़्यादा है वहाँ पे solvent move होगा, and because of that reason the water is going to move over here. That means water is moving out of the loop of Henle, descending loop of Henle से पानी कहाँ जाएगा, बाहर जाएगा. The same thing is happening over here as well. If you can notice, the same thing is happening over here, highlighted by the white part. पानी बाहर जा रहा है. Similar thing will happen in the deeper sections of the medulla as well. Because of the changes in osmolarity, water is moving out. और जैसे जैसे पानी बाहर जा रहा है हर स्टेप पे, the inner osmolarity is increasing because now पानी बाहर ज्यादा हो रहा है as compared to the inner solute concentration. So because of that, from the osmolarity of 300 at the end of innermost medulla, the osmolarity has come to 1200. अब जैसे ही 1200 तक reach हो जाएगी, now the ascending limb of loop of Henle is going to start, and because of ascending loop of Henle, now it is moving out towards the cortex. Towards cortex जा रहा है, यानी again the osmolarity of the external interstitium is going to decrease, whereas जो inner conditions है, inner conditions already 1200 तक पहुंच चुके हैं. Now what is going to be the case? Now again it needs to balance, and for the balance, now in this case the ascending limb is going to allow the solute, that is it is going to allow the salts, that is NaCl, to move in and out freely. So now in this case the ascending limb, the NaCl is going to move, and because the NaCl is moving, the osmolarity is going to get matched to the external interstitium, and from that जो 1200 तक reach हुआ था वो 300 हो जाएगा, and then the filtrate is going to move to the DCT. Now since it has covered the major part of the loop of Henle में ही counter current mechanism होता है, and loop of Henle is only one of the important site which is going to help in concentration of the urine. So once major concentration is completed in loop of Henle, it will move to the DCT, जहाँ पे again there is going to be water coming out depending upon the case of dehydration. If the person is dehydrated, what will happen? The body is going to signal to release water from the DCT. DCT को बोला जाएगा कि जितना ज़्यादा से ज़्यादा water you can reabsorb, you take it. Because the person is dehydrated, it needs more water. And from where it will take? It will take from DCT reabsorption. But if the person is well hydrated, dehydration की condition नहीं है, then what will happen? Lesser amount of water will be reabsorbed, and because of that the urine will be less concentrated. DCT ने सारा पानी reabsorb कर लिया. What will be the condition? The condition is going to be urine is concentrated. And when urine is concentrated, it might be sometimes smelly, it might be dark yellow in color, and all that things can be understood because of dehydration. DCT ने पानी ज़्यादा absorb कर लिया. And once now it has come entered into the collecting duct, it is the urine. And sometimes from the urine, a little amount of urea is going to move out from the collecting duct. Now, why is the urea moving out? The urea is moving out because to form the medullary interstitium osmolarity. So, जैसे हमने बोला कि बाहर की ऑस्मोलैरिटी 600 है, अंदर की 400 है, पर बाहर की 400 अंदर की 400 बिकॉज ऑफ द फिल्ट्रेशन प्रोसेस, बट बाहर की 600 कैसे हुई? बिकॉज फ्रॉम द बर्थ this little urea is coming out each and every time, and because of that the urea getting settled down. So जितना ज्यादा नीचे ग्रेविटी की वजह से यूरिया जाके कहाँ सेटल होगा? सबसे ज्यादा कॉन्सेंट्रेटेड नीचे होगा. सो जितना ज्यादा यूरिया नीचे है वहां पे क्या होगा? वहां पे सबसे ज्यादा ऑस्मोलैरिटी होगी 1200 मिली ऑस पर मोल. जैसे जैसे ऊपर ऊपर की तरफ आओगे, ऊपर ऊपर क्या होगा? डेंसिटी और concentration is going to reduce, and because of the concentration is going to reduce, what will happen? The osmolarity is going to decrease. But this osmolarity that is changing is going to take place in some time. ऐसे नहीं है कि आज यूरिया स्टार्ट हुआ है निकलना और कल तक पूरा का पूरा osmolarity डेवलप हो गया. No, it is not going to happen. It is going to take some time, and slowly and steadily it is going to develop into a fully functional interstitium fluid osmolarity. So हो सकता है कि बच्चों में जैसे यूरिनेशन बहुत ज़्यादा frequent हो because the concentration of the urine is not taking place very well because of the medullary interstitium is not well set. So as in adults and kids, you can understand why the urine output is more or why there is frequent urination, because of these, that the urine urea had not been set और उसको ज़्यादा time नहीं मिला है to set that medullary interstitium fluid maintenance. So that was all about the mechanism of the concentration of the filtrate. So filtrate में majority काम कहाँ हो रहा है? It is occurring in the loop of Henle, and it is very important if you understand that which limb is allowing the movement of which material. जैसे descending limb water को allow करता है, but the ascending limb allows NaCl for free movement. So if you understand that, and if you understand the concept of solvent moving from where to where, it might be very easy for you to understand the mechanism of concentration. So that was all for this part of the chapter, that was about formation of urine. If you like this video and get some help, then don't forget to like, share and subscribe to our channel. Till we come back soon with one more part of this chapter. Till then, keep smiling, keep studying. Bye bye everyone. Thank you.